Hey there guys, this is your notes for 1.5, function notation, day 1. Now before we get into function notation, we're going to start with evaluation of a function. This is a function or an equation. You may have seen them before. Now usually you may see letters within your functions. Now we call these letters variables. So we have an x variable and a y variable. Now we want to be specific. We don't just want to say we have an x variable. We want to say our x variable is our input variable. And our y variable is our output variable. So what we mean by input and output, depending on what we use for x, it will change what we get back from y. So you kind of think of it as a machine. You input something into your equation, and depending on what you input, you get something else out. But that's not the only definitions we want to have. We also want to talk about numbers without variables, which we call constants. So a constant is a number that has no variable. It is just a regular number. So like 5, 13, -7, -8, those are constants. The number next to a variable, although it is a regular number, is attached to a variable. We call this the coefficient of a variable. So this variable has a coefficient of 5. If there was a 7 in front of this variable, we would say it has a coefficient of 7. Now, an equation is a mathematical sentence with an equal sign. So this is telling you what's going on. It's a set of instructions detailing how to find an output value y given an input value of x. So here's our general steps. First, we're going to circle and highlight a given variable, substitute or plug in a variable with a given value, and then simplify using PEMDAS. So, parentheses, exponents, multiply, divide, add, and subtract. Let's start off with an example of x equals 2. This will be our input. This is what we're putting inside our machine. So we need an equation. So we're going to use this equation. So, using our regular equation, we have y equals 5x plus 7. So it told us first step, circle or highlight the given variable. So our variable is x, and they gave it to us. They gave us x equals 2. Then we're going to substitute, plug in with the given value. So y equals 5. When we substitute, we put parentheses. Parentheses are kind of placeholders because 5x really means 5 times x. So anytime we have a coefficient in front of a variable, those are being multiplied. So to show multiplying, we're going to use our parentheses. And inside this parentheses will be the value that we know x to be, which is 2. And then everything will stay the same. From here, we use PEMDAS. Parentheses first, so 5 times 2, which is 10. Bring down my plus 7. 10 plus 7 is 17. So when x equals 2, we put it into our equation, we get an output of x equals 17. So let's do some more examples. We have a new equation, actually a same equation with the same problem. So we still have x equals 2. So this one we know that when x equals 2, y is 17. When x equals 2, y is 17. These are two ways of writing the same problem. Now don't forget parentheses this way really represent the coordinate points x, y. Because we can use equations, and we will eventually use equations to plot points on a graph. So this would tell me I have point x at 2 and point y at 17. But let's try a different equation, part B. y equals 3 multiplied by the quantity of x plus 5 for x equals negative 6. So my first step is to circle my given variable. Well, they gave me x equals 6. Then I'm going to rewrite my problem. Y equals 3. X will go here, plus 5. Now the variable they gave me was negative 6. So instead of writing x plus 5, I will write negative 6 plus 5, because negative 6 is equal to x. So anywhere I see an x, I can replace it with the negative 6. Now I do PEMDAS, so parentheses first, negative 6 plus 5. Is negative 1, so we learned that on our integers day. And finally, 3 times negative 1 is negative 3. So for x is negative 6, we get y is negative 3. Or we get the coordinate point negative 6, comma, negative 3. Finally, we have, for at least evaluating, this new equation, y equals negative x plus 9 for x equals 4. So I'm going to circle my given variable, which is x, and they tell me x equals 4. So anywhere I see this x, I can replace it with 4. So y equals, keep the negative here. I'm going to plug in this 4 plus 9. Now be very careful. A lot of times what students will want to do is they'll want to put, oh, this is a positive 4, so they'll only put 4 plus 9. But this negative is separate from this x. So you still have to write out that negative and then plug in the 4. So now it becomes a negative 4 because it's negative x. So it's turning all your x's to the opposite sign. So this positive will become negative. And then you solve. There's no parentheses, it's just regular addition. We've done integers day, so we know negative 4 plus 5 plus 9 is 5. So for x is 4, y is 5. Or coordinate points 4, 5. So that's evaluating a function. Now we are going to get into actually function notation. Now function notation and evaluating functions are the exact same thing. Function notation is just a fancy way of evaluating a function. So instead of saying evaluate the function of the given value x, we shorten it to just f of x. And it's the exact same problem with the exact same steps. So the main thing you have to know is that anytime you see f of x, it's really y. So this f of x equals 5x plus 7 is the same thing as y equals 5x plus 7. They mean the exact same thing. So if we relabel this, this whole thing you pronounce as f of x, or function of x. The f is the name of the function. So our function is called f. We can have g of x, h of x, k of x, l of x. It could be any letter. They're just different names, is how we name our function. This is still our output. So since f of x equals y, y was still our output variable. So this is still output. This is still our input. This 7 is still a constant. And the 5, the number touching a variable or in front of a variable, is still our coefficient. So this equation has a coefficient of 5 with a constant of 7. Remember, a constant is a number without a variable. A coefficient is the number in front of the variable, and a variable is a letter in our equation. So we have find f of x, and that's, my bad, find f of 3, because there's not an x, there's a 3, find f of 3 for the given function above. Now this is telling us something important. F of 3 If there is a number within your parentheses and it is given to you, this means x equals 3. So f of 3 means x equals 3. And you do the exact same thing you did for the last one. You have your original equation, y equals 5x plus 7, except this time we have it as f of 3. We're going to circle our given variable. And remember, a coefficient touching a variable means they're being multiplied. If x equals 3, I'm going to plug in a 3 there. Plus 7. And then I'll just use PEMDAS to solve. Multiplication first. 5 times 3 is 15. Bring down the 7. 15 plus 7 is 22. So f of 3 equals 22. Which, remember, f of x is y, so this is just saying when x is 3, y is 22. Now find f of negative 3. Well, f of negative 3 means x equals negative 3. And we'll solve it the same way. Now, since it still says f, that means we're using the same function. Since they both say f, it says, hey, use a function named f. So the one above here. So we have f of negative 3 equals 5 times, because these are being multiplied, negative 3, my given value, plus 7. 5 times negative 3 is negative 15. And then I solve. Now be careful. 15 plus 7 is 22. Negative 15 plus 7, since 15 is bigger, that means our answer is going to be negatives, and it's going to be negative 8. So for this equation, when x equals 3, we have an output value of 22. However, we can also have an input value of 3. So when I put 3 into this equation, I get an output value of negative 8. Now these will be ones you practice on your own in class. So we can go through these relatively quickly. We have g of x, which is still the same thing. This still means y equals x minus 3, except now our function is named g. Find g of 0. So first step, circle the given one, and we're going to replace all my x's. So here's another x with 0, because g of 0 means x equals 0. So g of 0 equals 0 minus 3. I replace this x with a 0. 0 minus 3 is negative 3. So g of 0 equals negative 3. Here we have h of x. Remember, the letter doesn't matter. This is a different function, so it has a different letter name. So this function of h, we want to find h of negative 2. So we're going to circle every time we see x, and we're going to replace it with negative 2. So h of negative 2 means x equals negative 2. So h of negative 2 equals 2 times negative 2 plus 5. PEMDAS tells us do parentheses first. So 2 times negative 2 plus 5 is 3. 2 times 3 is 6. So h of negative 2 is 6. Finally, we have this more involved equation. J of x equals 10 minus the quantity of 2x plus 4. Find, ooh, this is a typo. That should say j of 2. So j of 2 means x equals 2. So everywhere I see an x, I'm going to replace it with the 2. So j of 2 equals 10 minus 2. Now be careful here. Remember, when there's a coefficient in front of an x, that means they're being multiplied. So 2x, I'm not going to write 2 and then a 2 next to it because that'll be 22. I'm going to put a parenthesis so I know they're being multiplied. So j of 2, I'm going to put in a 2 where there used to be an x. So 2 times x now becomes 2 times 2, since x equals 2. And then don't forget the plus 4. Parentheses first, so multiply within the parentheses. 10 minus 2 times 2, which is 4, plus 4. So 2 times 2 is 4, that's where this 4 came from. This 4 stays. Still parentheses, we still have to do it. 4 plus 4 is 8. 10 minus 8 is 2. So j of 2 equals 2. And that is our answer. So these are the notes for section 1.5 function notation. If you need help, feel free to sign up for tutoring. Otherwise, have a nice day.